so again, they've just given us an equation. They haven't told us what any roots are, so we have to come up with what a possible rational solution, or so it's a real solution for each equation. So we do that by finding our constant term. Remember, that's the last term of the equation, and then your leading coefficient. That's the very first number in your equation. So our leading coefficient is 4. And then what we have to do is we have to list out our factors of each coefficient, or each term. So factors of 8, so I know that 1 times what equals 8? 8. So plus and minus 1 equals 8. Can 2 go into 8? Yes, 2 is a factor of 8. What would be the next number that would be a factor of 8? 4. And then lastly, we would have 8. Factors of 4, obviously plus and minus 1. What else? Plus and minus 2. And then last would be plus and minus 4. So to come up with our possible solutions for our equation here, we take P, we're going to say this is P, and this is Q. We're going to take P and divide it by Q. Are y'all okay with that? So 1 over 1, what does 1 over 1 simplify to? 1. What about 1 over 2 simplifies to 1/2, right? All right, so we did 1 over 1, 1 over 2, and now we've got 1 over 4 next, right? All right, so then we have plus and minus 1 over 4. Now we go to our next P value. 2 over 1, what does that simplify to? 2. 2 over 2 simplifies to, but look, what do we already have? So do I need to write it again? No. Then I've got 4 over 2. What does 4 over 2 simplify to? 2. We've already got it, right? Then we have 8 over 2, which simplifies to plus or minus 4. Now we've got 1 over 4. Or no, we've already done that. 4 over 1, which is 4. We already got that. 4 over 2 is 2, and 8 over 2 is 4. Now we got 8 over 1 simplifies to 8. 8 over 2 simplifies to 4. We've already got that. And 8 over 4 simplifies to 2. So this right here would be my list of possible solution, or possible solutions to my equation. Now let's try this second one here. So again, I'm going to list out my constant term. Yep. My constant term is negative 45, and my leading coefficient is 7. Nope, just 7. All right, my factors of 45, plus and minus 1, right? Does 2 go into 45? Nope. Does 3? You sure? 3 does. If you don't know that, look, we can just say 45 divided by 3. Yep. So 45 divided by 4. Nope. 45 divided by 5. Yep. 45 divided by 6. 45 divided by 7. 45 divided by 8. 45 divided by 9. 5. So 9 goes into it. So we got 1, 3, 5, 9. Next would be 15. And then 45. At least 7 is pretty easy for us. There's only 2 factors of 7, and that is 1 and 7. All right, so let's start. P, remember it's P divided by Q. So 1 divided by 1 is 1. 1 divided by 7 would just be 1 over 7. 3 divided by 1 is 3. 3 divided by 7 is 3 over 7. 5 divided by 1, 5. And then 5 over 7. 9 divided by 1 is 9. 9 over 7. 15 over 1 is 15. So y'all see what we're doing, right? 45 over 1 is 45, and then we've got 45 over 7. Yeah, it is.
Why do you like math so much?
Still always have.
Yeah, you just like dealing with numbers?
Yep. All right. Next, it tells us to use, it says a jewelry box measures 2x plus 1 inches long, 2x minus 6 inches wide, and x inches tall. The volume of the box is given in the function 4x cubed minus 10x squared minus 6x. What is the height of the box in inches if its volume is 28 inches cubed? So we take that equation they gave us, 4x cubed minus 10x squared minus 6x, and we set it equal to what our volume is. We said our volume is 28. And essentially what they're trying to do is trying to get us to solve for x, figure out what x equals. So in order for us to do that, we have to take 28 and move it to the left side. 4x cubed minus 10x squared minus 6x minus 28, and we set it equal to 0. So now it looks like one of those equations that we had just a minute ago. But instead of us listing out all those factors, I'm going to show you a different way we can do to find a real factor, okay? So I go to my calculator and I put my equation in there. I've got 4x raised to the third minus 10x squared minus 6x minus 28. And look at my graph. How many times does it look like this crosses the x-axis? It looks like it only crosses it once right here. Well, I don't know what that number is. We've been talking about zeros, so we know that we can call this a 0. So I hit the blue button, second, and then I go to trace. Well, what are we trying to find? We're trying to find a 0, right? So I make sure I'm on the left side of this line. I look for my little cursor. Oh, there it is. I'm on the left side. Now I go up to the other side. There's my cursor way up there now. And I hit enter and I tell it to guess. You see where it tells me my 0 is? At 3.5, right? How did I do it? Hit enter, enter, enter. Thank you. Thank you. Thank you.
Miss used to tell me to add paint to this osmosis.
Yeah, she took me.
Oh, okay.
And I did. You're welcome.
And I want some oranges.
All right. So when we did that, we got that x was equal to, let me do this again because it went away. X is equal to 3.5, I'm pretty certain. Okay, 3.5. So 3.5, and I'm going to change that to a fraction since that's what we were dealing with earlier, 7 over 2. So I'm going to put 7 over 2, and we're going to now use synthetic division with our equation. Remember, we just take the first numbers, 4, negative 10, negative 6, and negative 28. Bring down the first number. 7 over 2 times 4 is 14. Negative 10 plus 14 is 4. So again, 7 over 2 times 4 is going to be 14. Negative 6 plus 14 is 8. And then 7 over 2, or 3.5 times 8 is 28. And remember, this last column is always our what? Remainder. What's our remainder here? 0. So this tells me I've got 4x squared plus 4x plus 8, right? Well, if we're not paying attention to this remainder, we're just paying attention to our equation right here. What do these three numbers have in common? They're even, but what else do they have in common? We could take the 4 out, right? So 4 times x squared plus x plus 2. Well, I'm going to be honest with you. There's nothing that will multiply to give me 2, or there is no real number that will multiply to give me 2 and add to give me 1. Only things that multiply to give me 2 are 2 times 1, right? So, this tells us, I'm going to draw a little arrow, and I'm going to say not factorable. Since this is not factorable, this tells me that this number inside our box here is our only real solution, okay? Since that is our only real solution, that tells me that x has to equal this number. So I'm going to say x equals 7 over 2, because that was our only real solution. This says our jewelry box measures 2x plus 1 inches long, 2x minus 6 inches wide, and x inches tall. And we are looking for the height of the box. So we are paying attention to this formula right here, correct? So if it's x inches tall, the height of my jewelry box is 7 over 2 inches, or you may even write it as 3.5 inches, okay? Example 3, they want us to find all the roots of the equation x cubed minus 2x squared plus 5x minus 10. So I'm going to put that in my calculator. X cubed minus 2x squared plus 5x minus 10. And I graph it. Did I put this in there? Alright, yeah, I did. Alright, so when I look at this graph, how many times does it look like this crosses the x-axis? Once. So I'm going to find that 0 again, just like we did. Make sure I'm on the left side of that graph. Alright, I'm on the left side, then I make sure I go to the right side, and it tells me my 0 is at 2, 0, and I accidentally hit the wrong thing, but it said 2, 0. So I'm going to come over here and just write x equals 2, just so I know that that is one of my real zeros, okay? So what I do is I use synthetic division, but we say x equals 2. X cubed minus 2x squared plus 5x minus 10. Bring that down. 2 times 1 is 2, so negative 2 plus 2 is 0. 2 times 0 is 0. 5 plus 0 is 5, and 2 times 5 is a positive 10. Remember, this last column is always our remainder, right? So this is 1x squared plus 0x plus 5. Now that we have it as a quadratic, I've got x squared plus 5 is equal to 0. I do not have to use a quadratic formula. We could use the square root method. So we subtract 5 from both sides. And now to get x by itself, we take the square root. So I've got x is equal to, what do we always take out if it's a negative? I. So x is equal to plus or minus I times the square root of 5. Can the square root of 5 be simplified any further? Nope, that's as far as it gets. So I know that x equals 2, x equals I square root 5, and x equals negative I square root 5. Those are my 3 zeros. Everybody's got this page? Suppose a quadratic polynomial function has two complex zeros. So it's quadratic, that just means it's going to be x squared something. They are conjugate pair, a minus bi and a plus bi, where a and b are real numbers. Are the coefficients of f real? Explain. So basically they're telling us that I've got two roots. I've got x minus a minus bi times x minus a plus bi. We're going to do it with these letters, but example 5, we're going to do it with some numbers, and I think it'll make a little more sense to you, or I hope it will. So what they have us do is they have us distribute the negative in this, or into both equations here, or parentheses. So now I've got x minus a plus bi times x minus a minus bi. So at this point, they have us regroup it so that it is, or so that we can write it as the difference of squares. So this is going to be my first term, and bi is going to be my second term. So I'll rewrite this as x minus a squared minus bi squared. That's using the difference of squares. You may be thinking, well, how do I know what this is? If you want to use your box method, you can, or if you just want to write it out like this, you can do that as well. But we've got x squared minus ax, so I'm distributing minus ax plus a squared, so I'll combine my like terms. So x squared minus 2ax plus a squared. So x minus 2a, or x squared, excuse me, minus 2ax plus a squared. So I squared the first one, right? Minus, so now we're going to square bi, which is the same as bi times bi. B times b would be b squared. I times I is I squared. Remember back from chapter 2, we said that I squared equaled negative 1. So b squared times negative 1 is just a negative b squared. So minus b squared. So guys, my final answer here would be x squared minus 2ax plus a squared minus a negative b squared, so that makes it plus b squared. And like I said, I know sometimes when you're dealing with letters, it makes it a little bit confusing for you. but we're about to put it with some numbers, so hopefully it's not. Did everybody have this? What is a quadratic equation in standard form with rational coefficients that have a root of 5 plus 4i? If it has 5 plus 4i, that also means it's going to have 5 minus 4i. Brenda, you got a question? So because these are going to be our roots, x minus 5 plus 4i and x minus 5 minus 4i. So we're going to write our quadratic equation. X minus 5 plus 4i times x minus 5 minus 4i. We distribute just like we did in example 4. So I've got x minus 5 plus, not plus, that should be minus 4i. And then I've got x minus 5 plus 4i. All I did was I just distributed out the negative for both. And then what we just did is like we did in example 4, we're going to group together the x minus 5s. And then use the difference of... Okay. So we group this together. We've got x minus 5 squared minus 4i squared. X minus 5 squared. If you need to write it out somewhere, you could probably write it out up here. X minus 5 times x minus 5. X squared minus 5x minus 5x plus 25 is going to give me minus 10x plus 25. X squared minus 10x plus 25. So I actually came over here to square the 4i, which is 16i squared, or 16 times negative 1, which is negative 16. So minus a negative 16. So I've got x squared minus 10x plus 25 plus 16. So my final equation that would give me the two roots of 5 plus 4i. What's 25 plus 16? 41. So basically they're telling us if we were to put this in the quadratic formula, we would get the answer of 5 plus 4i and 5 minus 4i. All right, this now tells us that we have a polynomial function q with degree 4 that has the rational coefficients of 2 minus 3 and 5i. So, q of x, I'm going to do this in a different color. So it tells me it has the roots, so we got x equals 2 minus the square root of 3, or that should really be, x minus 2 minus the square root of 3, x minus 2 plus the square root of 3, 5i, so x minus 5i, and x minus a negative 5i. So I'm going to write these out in parentheses, x minus 2 minus the square root of 3 times x minus 2 plus the square root of 3, x minus 5i, and x plus 5i. So I've got x minus 2 plus the square root of 3, x minus 2 minus the square root of 3, x minus 5i times x plus 5i. We're going to use difference of squares twice. We're going to use it right here, and we're going to use it right here. So this is going to become x minus 2 squared plus the square root of 3 squared. Or not plus, that should have been minus. Sorry, guys. Minus. And then I've got times x squared minus 5i squared. I'm doing my multiplying right here just because it'll be a little bit easier for me. So x squared minus 2x minus 2x plus 4. If you needed to write it out, you would have written it out as x minus 2 times x minus 2. Don't close that parentheses. Square root of 3. Squared is just 3. So plus 4 minus 3. And then I have x squared minus 5i squared is 5i times 5i, which is 25i squared, or negative 25. So minus a negative 25. Combine any like terms. So now I've got x squared minus 4x plus 1 times x squared plus 25. So guys, to make this a little bit easier on me, I know we haven't used this all year, but we can use it today just so you kind of see. Y'all familiar with the box? X squared plus 25, x squared minus 4x plus 1. You just multiply all that out and then combine your like terms. So my final answer would have been x to the 4 minus 4x cubed plus 26x squared, because we combined this term and this term, minus 100x plus 25 equals 0. what time did I say y'all dismiss? 45 or 40?